Hi, Julian. How are you today?
Hello, I'm good. How are you?
Have you already woke up?
Yeah, it's fine. I'm really happy to speak to all of you this morning. I wish I could be in Ukraine, and I've been there many times. It's a place that I really like. Unfortunately, we have to stick to online videos, but I really hope we can soon be in the same room and have a great conversation. The sooner the better.
Yes, I hope. Let's do it next year. Let's imagine. And what topic have you prepared for us today?
Well, this morning we're going to, I think, start the day in style. It's an introduction to machine learning, what machine learning is, how can you easily get started with your machine learning project, sharing some best practices, and then walking through and demoing some of the services that AWS has built for people who are just beginning with machine learning or people who already have a bit of experience. So yeah, lots of real life advice and of course lots of demos and code, right? Which is what we like.
The stage is yours. I'll come back after you'll finish.
All right, thank you very much. Okay, so let me share my screen, full screen, and we can get started. So again, good morning, everybody. Thank you very much for joining me this morning. We have a long session. We have lots of stuff to cover. So my name is Julian. I'm a tech evangelist working with AWS. I've been working with them for about 5 years now, and my role is to help developers and customers understand how to build quickly and easily with AWS services. So, like I said, we're going to start with a primer on machine learning because, I'm guessing lots of you, most of you have never really practiced machine learning. So we've got to get our definitions right, understand what this bizarre thing is, and what are some of the technical issues and challenges that we need to focus on. Okay, so we'll start with that. Then we'll talk about starting your machine learning projects, figuring out which tools to use and how to organize the projects, which is, I think, a really important topic if you want to be successful. And then we'll start looking at services. Okay, so let's start with a few basic definitions. Okay. Whoops. All right. All right. Okay, so the first thing is we hear constantly about AI and machine learning. Is there a problem with the screen? Oh, you don't see the full screen. Okay, that's okay. Let me try screen sharing again then. Looks like not sure which screen it's sharing. Okay, it's kind of weird because I'm sharing the right one, but okay, anyway. All right, we'll figure it out. No worries. Okay, here we are. Okay, so here we are now. Fine. So the first thing we need to get clear, to get out of the way, is AI versus machine learning versus deep learning. You hear those words thrown around constantly, and not everybody's super clear on what they mean. So really quickly, just to set the scene, AI is the high-level domain, right? AI is a 60-plus-year-old domain, and it's focusing on designing and building software applications which exhibit human-like behavior, right? So building apps that can use and understand speech and recognize images or videos, use natural language, and show some kind of reasoning, intuition, the ability to solve complex problems. So of course, inside of AI, you have tons of different domains over time, and again, expert systems and computer vision and speech synthesis. You have lots of different things in there. But as it turns out, one of those domains, which obviously is machine learning, got very successful because it just proved to be very effective at solving hard problems, pretty much. And so machine learning is a capability for machines to learn from data sets using statistical algorithms, okay, without being explicitly programmed. And what I mean here is, of course, when you write, let's say, business rules in your business applications, you explicitly state what you want to achieve, right? You want to, you manipulate data, you process it, and you get some kind of output, and that's your answer. So it's really your code explicitly doing whatever needs to be done on the data. Machine learning is completely different. Machine learning starts from data sets where features, so let's say columns, right, variables, are clearly visible. Imagine, something like looks like an Excel sheet, or a CSV file. It's pretty clear what those columns are and where they come from. And then you use probably off-the-shelf algorithms to learn how to predict a certain value in this data set. Okay, so that's the main difference. Instead of writing your application code, you use existing algorithms to extract patterns and insights from data sets. And deep learning is a subset of machine learning. It does the exact same thing, except it's focusing on a single technology, and that's obviously neural networks. Okay, it uses neural networks, all kinds of different architectures, to extract information from complex data sets where features cannot usually be easily expressed, right? Think about, again, images, videos, speech. It's not easy, you can't put that stuff in an Excel sheet. That's what I mean, right? What are the features in a picture? What are the features in a music clip? It's not obvious. So neural networks are great at figuring out automatically what the patterns, what the useful information is inside those data sets, right? And they're very mysterious and complex, but they're great at this. Okay, so artificial intelligence, high level topic. Inside of that, machine learning. Inside of machine learning, deep learning. Okay, so now that we're clear, let's talk about the main two ways you can do machine learning. So the most common way, I would say, is supervised learning. So it's exactly what the name says. You will show the algo what the correct answer is on your data set, and the algo will learn how to correctly predict this answer. And if the model is built correctly, it's going to be able to generalize to other data, right? To data that obviously the model has never seen before. Okay, so the key thing here is, of course, you need to label the data set. So for example, if you're building, let's say, a fraud detection model for credit card transactions, you're going to say, okay, this transaction is legitimate, this one is legitimate, this one is fraudulent. And the model will learn how to correctly predict the right answer. Okay, and as you can imagine, building the data set, labeling the data set is a lot of work, right? It's very time consuming, and we'll get back to that. So classification is a very popular use case for supervised learning. So it could be binary classification, yes or no, true or false, legitimate or fraudulent, those problems. You can have multi-class classifications where you try to classify, let's say, images in 50 different categories. And you can have also regression, which is basically a complex word to say, I want to predict a numerical value. I want to predict the price of a house. I want to predict the number of traffic jam kilometers in Paris tomorrow, etc., right? So that's supervised learning. And then you have unsupervised learning. And unsupervised learning, as you can guess, doesn't require a labeled data set. You start from the data set the raw data set, and that's it. Okay, and the model will, without any information, the model will find some patterns and organize samples. So a good example of that is clustering. Okay, grouping your samples according to their statistical properties. Okay, so trying to say, I think I have, let's say I have a customer database, and so I build a data set from the customer attributes, and I want to see how I could group customers in 3 groups, right? Because maybe I'm thinking, hey, I have, bronze and silver and gold customers, whatever that means. Let's see if a model can pick that up. Okay, topic modeling is a similar technique to group lookalike text documents that are based on the same words, right? So both techniques are really useful. So when would you use those? So this is really, this is not as clear cut as as this, but I would say in general, supervised learning lets you build very sophisticated models, very advanced models. So all the crazy computer vision and natural language processing that you see out there is based on complex supervised learning use cases. Okay, so that's the y-axis, and the difficulty here is usually those models require lots of data and lots of labeled data. So building the data set is going to be lots of work. Okay. Unsupervised learning lets you achieve less sophisticated tasks, like I said, grouping or simplifying the data set. But it doesn't require any labeling, and it usually doesn't require as much data, right? Because you're working with just the statistical properties, and it's enough to get the job done. You don't need a million samples to figure that out. There's another technique which I'm not going to discuss at all today, which is called reinforcement learning, which can work even in the absence of data. Reinforcement learning is based on letting an algo explore some sort of simulated reality and figure out by itself how to do the right thing. Okay, so things like playing video games, which is of course the popular thing, but the silly thing you can do with reinforcement learning. Reinforcement learning is heavily used in robotics, in the stock market, in energy management, all those very dynamic, very chaotic problems where building a data set is really just not an option, and so you have to do something different. Okay, but I won't discuss that today. So just to give you a sense of what those algos are, this is the list of algos, or some of the algos that are available in a popular machine learning library called scikit-learn, which I'm sure you've heard about. And so we can see the different topics here, right? Classification, regression, so predicting numerical values, clustering, so grouping things that are similar, and dimensionality reduction, which is a way to take, in a nutshell, data sets with a huge number of columns and reduce the number of columns to a smaller number, which simplifies training and removes correlation between all those columns, etc. So this is a really cool map, I think, because it shows that there are so many algos you can pick, and depending on what you're trying to do, you can go left or right, and even then, try potentially different algos for the same problem. So that's the kind of thing we have in mind when we say machine learning. Okay, start from data, figure out the problem we're trying to solve, and then go and experiment with different algos, build some models, see if they're accurate, and repeat. Okay, so just a quick example. Decision trees are a really popular family of algorithms. So it's a supervised learning algo. And the purpose is we want to build a decision tree that lets us go left or right based on certain feature values, and hopefully getting all the way down to the tree and getting the right answer, right? So, we're used to working with decision trees and flowcharts, and this is pretty much the same thing, right? So we start from a data set which has a number of features, a target attribute. So maybe it's the identifier for the class we want to predict. This is a fraudulent transaction, or this is a legitimate transaction. And so we look at features, we look at certain value thresholds. So if this feature is lower than this, then go left. If it's higher than this, go right, and repeat until we get to the bottom of the tree and we have our answer. Okay, so that's what we do here. And they're popular because they're pretty easy to understand. It's pretty easy to understand how those models predict, the whole explainability issue, right? And there are lots of variants. I'm sure you've heard about XGBoost, which is a very, very popular algo out there. Okay, so this, when we say machine learning algo, this is what we mean, and the name of the game is to figure out all those parameters automatically. Okay, which features do we use to split? Which thresholds do we use to split left or right? So that's the purpose of the training process, getting to those parameters. Okay. So if we step back a little bit, then the machine learning cycle looks something like this. Okay. We start with the business problem. Okay. And that sounds obvious, but trust me, some people want to jump to neural networks within 5 minutes because they think it's the answer. But I always advise you to step back, have a cup of coffee and think about what is it you're really trying to solve. Okay, so maybe you're trying to classify images, maybe you're trying to classify fraudulent transactions, maybe you're trying to translate French to Ukrainian, etc., etc. Okay, and then you can start framing the problem, which really means understanding how this could be a machine learning problem. What kind of data would you need? What kind of algo maybe would work? How much accuracy could you probably expect from that? Okay, and not all problems are machine learning problems. Sometimes you'll figure out, well, no, data cannot really help me, so I need to find something else. So assuming it is a machine learning problem, then there's a whole bunch of tasks related to collecting data, cleaning, preparing data, putting everything in the same place so that your data scientists and machine learning engineers can start experimenting with it. And this step, if you talk to data scientists, they'll tell you this is anywhere between 50 to 80% of their time. It is the dominant task in machine learning. Then you can start experimenting, visualizing, computing some statistics, maybe building some features, some extra features in your data set to make it more expressive. And then you can move on to training and tuning the models and measuring accuracy. You will usually iterate quite a few times until you get to where you want to be. And then at some point you have a model that you like and you can go and deploy it and use it for predictions. And probably that's where the real problems start, because you're in production land now. You're not in your machine learning sandbox. So if you deploy models that are used 24/7 by business apps, then monitoring, scaling, debugging, logging, all those good things become really important. And at some point you will have to retrain to account for new IDs, new data, etc. So that's the machine learning cycle. And you can see, obviously, you're going to iterate constantly here, right? And you're going to need all kinds of tools and all kinds of infrastructure to do that. Okay, so that's what we're talking about when we say, hey, I'm working with machine learning, not just neural networks, not just algos. There's a whole bunch of other things to be dealt with, especially data collection, data preparation, and all the operations related to machine learnings in production. Okay, so this is probably more complex than you thought, right? This is probably not as simple as, oh, I can just click and train a model. So let's move on to how you can actually get started with this. Okay, how can you actually start entering that machine learning cycle, right? So the first thing is you need to set expectations, right? People have all those crazy ideas about machine learning, and it's crucial that you know what the target is. So what's the business question you're trying to answer? Okay, and it should be simple. It should be one sentence on the whiteboard. It must be quantifiable. Okay, it must be very clear what you're trying to achieve. So for example, we want to detect fraudulent transactions with an accuracy higher than 99%. Okay, or we want to I don't know, we want to forecast our monthly revenue within plus or minus 1% of error, etc., etc. Right? Something simple, something crisp, something you can quantify. Okay. Then the second thing is, do you actually have data to do this? Because by now you know machine learning needs data. So if you have zero data, well, that's something you need to think hard about. Okay. Do you have that data? Can you even collect it? Right? Can you even find, buy, or partner or with someone who has that data? Okay. Then you need to involve a lot of people. It's not just data scientists, right? It's a business problem, so you need business people to make sure everybody understands the implications. You need IT people because they will be managing your models, and ops people as well. And of course, you need data engineers and maybe DBAs and of course data scientists. So it's a group effort. It's not just someone in a dungeon somewhere with a bunch of data sets who's going to come with a magic solution. That's not happening, right? It's everybody has a piece of the puzzle, so you need all those people around the table. So these are red flags that you should look for. So if somebody, your boss or a customer, anyone says, we want to see what this technology can do for us, this is not a business question that you're trying to answer. This is not quantifiable. Okay, so this is a red flag for me. This is another one. And by the way, these are all real life examples. I'm not making this up, right? I still hear this on a regular basis. We have tons of relational data. Surely we can do something with it, right? And I can't see you, but I'm seeing some of you say, yeah, that's what I heard last week, right? I'm sure you hear that stuff. And my favorite, which is, I read this super cool article about Foobar ML. We've got to try it. The hipster, hype-driven technology syndrome. That's awful. So no, that's not working. So all that stuff is a no-go. Just don't do that. Okay. Just don't do that. Find a real problem to solve. Okay? Yep. Nope. Hell no. Right? So you got to be strong and fight against this. The second thing is you want to define clear metrics. Okay? So what's the business metric showing success? Because at the end of the day, if you're trying to solve a business problem, it has to have some positive impact somewhere, right? So think about that. Do you have a baseline that you're comparing against? Maybe you're trying to automate a human workflow, or maybe you have a legacy IT system that's kind of doing the same thing and you want to replace it with machine learning. So what's the baseline here? What's a significant but reasonable improvement, right? Again, machine learning is iterative, so just define what would be considered successful, but be reasonable, okay? And think about the improvements. So maybe you could say, all right, we want to reduce fraud detection errors by 5% every quarter or every semester, and then that's good, right? It's a long-term thing. So again, machine learning is full of jargon and mumbo jumbo. It's quite bad. And unfortunately, it's difficult sometimes for machine learning experts to express progress, right? So if a data scientist tells you, that person's super excited, they come to your desk and they say, the confusion matrix for a support ticket classifier has significantly improved. If you're not a machine learning person, you're going to go, what? And then that person's going to say, well, you understand, P90 time to resolution is now under 24 hours. I'm like, yeah, okay. Why do I care? So with a little more conversation, you're going to get to the impact is, misclassified emails. Let's say this is a support use case, right? A customer support use case. So misclassified emails have gone down 5.3% using the latest model. So, okay, that sounds like an improvement, okay? But at the end of the day, the business metric you want to see progress on is how happy are your customers, right? So if then you get to the latest survey shows that very happy customers are up 9.2%, yeah, that's good, right? That's something you can go to the CTO or the CEO or whoever and say, see, this model really works. So that's the kind of thing you want to look for. That's the kind of metric you should have in mind. And of course, you need the technical metrics and you need the crazy ML metrics. They're important, but they need to be related to actual business metrics. The third thing is you need to assess what you really need and not what you want, right? And of course, with respect to your skills. So can you build a data set that describes the problem, right? Is that something you can do? Can you clean, prepare, curate it over the long run? Do you have those tools? Do you have those skills? Can you write and tweak machine learning algorithms, or is that out of scope? Can you manage ML infrastructure, and is that really needed? So the point here is, as you will see, in a few minutes when we start talking about services, there's a very large scope of services here, right? So from the fully managed, click and get the job done to do everything yourself, there's really a very wide range of things here. So you need to figure out where you stand on that in that spectrum. What do you need? What's the shortest path to success? Then once you have, kind of an idea where you are, of course, you need to pick the best tool for the job. And well, there is no silver bullet. So if you have to pick between cost, time, and accuracy, you only get to pick two. Okay, sorry, life is hard. So you can have a very inexpensive solution and bring it quickly to market, but it's going to be less accurate, right? And on the contrary, if you want a very accurate solution and you want to, you're ready to spend some money on that. Time to market will be longer because you need to invest more and you need to just work harder at getting the extra accuracy. So you only get to pick two of those things, right? So pick the right ones. So again, the least expensive and the fastest option is probably not the most accurate. Still, it's enough to get started, maybe, and understand the problem. Yeah? Build maybe a POC, demonstrate some initial business value, and get some buy-in, get some sponsoring for your project to actually go deeper into ML and build a longer-term project. Okay. And yeah, improving accuracy will increasingly take more time and money, right? It's not too hard to get to 90%. It's hard to get to 95. It's crazy hard to get to 99. And it's unbelievably hard to get from 99 to 99.5, 99.6. And of course, the more you want, the harder it gets. So it's really diminishing returns. So you need to know when to stop. Right? At some point, it doesn't make any sense to go and chase extra digits because you've got good enough accuracy and the cost versus benefit ratio is just not there. Okay. There's a lot of talk about state-of-the-art models, and it's very easy to get excited with all the crazy models that are out there. I would say you have to be pragmatic, you have to be reasonable. So anything that is actionable right now based on your skills and resources could be interesting, right? So techniques like transfer learning, AutoML, etc., they definitely need to be looked at. But be careful. If you read about this fantastic new model designed by whoever, one of the technology leaders in the field, it might be extremely complicated to use, and it's not because it worked for them that it's going to work for you, right? So again, hype-driven machine learning is dangerous, and it will usually be disappointing. So stay pragmatic. And of course, you need to use best practices. Okay, so that's one thing I'm constantly fighting. No, things are not different this time. AI and machine learning is software engineering. It's not something else. Okay, we're still working with software tools. We're still working with data. We're still working with infrastructure. We're still trying to deploy stuff in production that works. So how is that different from everything we've been doing in the last 30 years or 50 years, right? So, using development tools, development environment, having QA, having documentation, using agile techniques, versioning, etc., etc. Everything that you use as a software developer still applies to machine learning. This is a very controversial opinion. This gets me into a lot of very heated discussions with data scientists and researchers. But okay, I'm happy to have the discussion again and again and again. Okay, you need best practices. Again, some person in a dungeon with 6 months and tools that no one understands and no one can replicate in production is not going to lead you anywhere, right? We need experts, but we need solid industrial processes that can yield quality models in production. Okay, so the truth is in prod, so I would recommend getting there fast, as often as needed. Sandbox is nice, prod is better. Okay, so if you think about CI/CD automation and DevOps for machine learning is what I mean here, then fine, because otherwise that's what you're looking for. That's experimenting in production. And if you saw that movie, then you know how it turned out. It didn't go too well for some of these people. So everything looks okay when you're in the harbor, and then you go out sea, and things are a little different. So go at sea as quickly and as often as needed, and figure out what works and what doesn't work. And last but not least, iterate, iterate, iterate. Right? This is the most important thing. We saw this machine learning cycle, and by design, it is an iterative process. So start small, start with simple IDs, simple data sets, and simple algorithms, right? And learn and iterate. Okay, so always try the simple things first. Don't go for the crazy deep learning architecture that supposedly solves everything. Why don't you try linear regression? Why don't you try decision trees? Why don't you try the basic algos that you can understand? Maybe they're certainly not going to be accurate enough at first, but they give you a baseline. They give you some reference accuracy that you can then use to see if the other things that you try actually help improve that. Okay, go to prod quickly, or at least to your production environment where you have production data. Run some tests, observe prediction errors, figure out why this thing is not predicted right, and then decide what to do, right? So is my data set wrong? Is it incomplete? Do I need more data, or should I tweak or experiment with another algo? All these are possible options. Okay, and just repeat until accuracy gains become irrelevant to your business problem, right? And move on to the next project. Okay, so as you can see, machine learning, yes, can be complex and a bit mysterious, but there are proven effective ways to get started, provided that you focus on the business problem, you focus on your skills, and you focus on the objective you're trying to achieve, right? And then it becomes a little clearer which tools you should use. So talking about that, let's see how we can try and help you do this. Okay. So as you probably know, machine learning is quite a thing at Amazon, and here are some examples over the years. Of course, I'm guessing everybody is familiar with the product recommendation and personalization on the Amazon websites. It's really it's a now mainstream feature on all the retail websites out there. And of course, all that stuff is based on machine learning. But there's also tons of machine learning running under the visible iceberg. So all the back end and all the back office tasks at Amazon are heavily run by machine learning. So from logistics to delivery to customer support. You've certainly seen those Amazon robots moving around in the fulfillment centers. So if you ask me what's the secret at Amazon, well, the secret is customer obsession, of course, but the technical secret is probably machine learning, automating, making everything super efficient. And then, of course, we use machine learning to invent new product families like the Echo devices and the Kindle, etc. And all these, of course, use machine learning in one way or the other. And we have, more use cases like, the Amazon Go grocery stores in the US, where you just walk in and walk out without going to the cashier, because we automatically figure out which products you pick in the store. And drone delivery is being worked on as well. And again, all this stuff is based on ML. So we have some very, very cool stuff happening inside of Amazon. Now, of course, my job at AWS is to help you do the same, right? Is to help you use the services that we build, listening to your needs, and then show you how to use those services and get started. Okay, and it doesn't matter if you're brand new to this, if this is the first machine learning talk you ever attend, or if you're already doing it. We think we can help you deliver more interesting, smarter, more innovative applications and services to your own customers. So as it turns out, we see all kinds of customers. People often ask me, what's the typical customer for machine learning? And there's no answer to that question. It's literally everybody. We have tens of thousands of active customers who run AI and machine learning on AWS, large enterprise or startups and public sector and universities in all industry segments, right? People keep talking about financial services and retail, but it's also manufacturing and life sciences and education and sports, literally everything. So if you want to explore some of these references, you can go to this URL and you'll find customer use cases and quotes and lots of content showing you the extent of what AWS customers achieve using machine learning on AWS. So how do they do that? Well, it's time to start diving into the stack a little bit. And we have over time built quite a few services. When I joined AWS 5 years ago, you could fit all the AWS services on one slide. There were probably about 50 services when I joined, okay? And now we're getting to a point where it's difficult to fit the ML services on one slide, and it's certainly going to be even more difficult after AWS reInvent, our conference. I'll mention reInvent again at the end. So this is what we've built over the last 4 years. And as you can see, we've organized those services in 3 layers, okay? So today I'm going to focus on the top and the middle layer, and I'll say a few words at the end about the bottom layer, which is really more specialized and hardcore, right? So not exactly our topic today. So what are those 3 layers? So the top layer is called AI services. And what we mean by that is these are high-level services where for most of them, you don't need to do any training at all. Okay, you just call a cloud API, pass your data, get an answer. Okay, and I'll show you some, of course, we're going to do some fun demos in a few minutes. So things like analyzing images and videos, or analyzing speech, or analyzing text, etc., etc. Okay, so these are based on pre-trained models that we train and optimized on very large data sets so that you don't have to. Okay, call an API, get the job done. Now, in that layer, we have another group of services such as Amazon Personalized Forecast, Fraud Detector, where you can bring your own data, right? You can absolutely bring your own data set in a simple format. And by calling just a couple of simple APIs, you can train a model, but without the need for any machine learning knowledge, because the machine learning knowledge is built in, right? And I'll show you quickly Amazon Personalized, which is a service that lets you build recommendation models. And then we have a few more things. We have a machine learning powered search engine called Kendra. We have a chatbot service called Lex. We have a new pretty cool service called Code Guru, which is which uses machine learning for code reviews. Okay, so based on the pull request workflow, you send pull requests and to your on a repo, and of course, and Code Guru is going to inspect the pull request, and it's going to suggest, detect potential problems and suggest fixes. Okay, so that's pretty nice. And you can also do application profiling with Code Guru, detecting performance problems, bottlenecks in production. So for strictly the development part of the software engineering process, this is a pretty cool service. Okay, so that's the thing. So if you're completely new to AI services, if you're completely new to machine learning, AI services is probably where you want to go. Okay. Now, ML services are one level down. Okay, and here the rationale for this set of capabilities, which are part of a very important service called Amazon SageMaker, the rationale is that we want to give you full control over the machine learning process. So you can bring your own data sets in whatever format. You can bring your own machine learning code based on whatever open source library you use, or maybe your own custom code, right? So full control, full flexibility, but without having to manage any infrastructure, as we will see, right? Infrastructure becomes completely transparent, so you don't have to spend a minute on it, and you can focus on the machine learning problem. And on top of that, we bring high value machine learning capabilities that help you solve and go quickly through that machine learning cycle, right? So training, debugging, data preparation, data labeling, pretty much all the boxes in that cycle are covered, right? And these are really very high productivity tools that help you go faster from experimentation to production. And frameworks and infrastructure is exactly what the name says. So of course you'll find all the Amazon EC2 instances, CPU, GPU, FPGA. We have a custom chip called Inferentia. I'll say a few words about that. So all the infrastructure that you need to build your own ML platform inside of AWS, if that's your goal. And of course, we have software tools. We have prepackaged all the popular machine learning libraries inside Amazon Machine Images for virtual machines and inside containers, so that you can just go pick those tools and fire up whatever infrastructure you want to build. Again, saving you time, not having to install anything and getting to work quicker. Okay, so let's start exploring. Those services. Okay. So I'm gonna do some demos. So let me leave this. All right. Okay. Let me grab my browser here. All right. So we're not going to go through all of them, but I've picked a few that I like and I think you should like. And we can go and try this. Okay, so let's maybe try recognition first. Okay. So recognition is about analyzing visual content, images, videos. So here I'm using the AWS console. If you've never used AWS before, maybe I should explain. So the AWS console is a web app that lets you very easily use AWS services. So it's great for experimentation and learning and of course demos, right? And everything I'm doing here is based, of course, on APIs, right? So anytime you see me doing something here, I'm actually calling an API, which you could call as well, in your favorite SDK, right? Whatever language you want to use. So let's try let's try face detection. Okay. All right, Sam, let me pick an image. Okay, let's try this. Okay, so here what I'm doing is I'm uploading an image to the service. I could also pick an image that's hosted in Amazon S3 or storage service, and I'm calling an API in recognition, which is called detect faces. Okay, so we can actually see the request here, right? So we pass the image and we get a JSON response where we see bounding boxes, right? So coordinates for the faces, and we see attributes, right? So like I said, every time I'm doing something here, I'm actually calling a service API, and which you could call in Python, Java, PHP, using any of our SDKs. Okay, so we can see, all the faces in there have been correctly detected. Okay, and we see some attributes, and right there are a few more. So this is clearly a machine learning powered solution, right? Based on deep learning models, etc., etc. So of course you could try and build this yourself, right? You could try and train a face detection model on a large image data set. But is that really needed, right? I mean, if this works for you, and this is really one line of code called the detect faces API, and read the answer, then job done, and you can move on, right? So this works pretty well. Now we can do another thing with this. We can try and do celebrity detection, right? So you'll know best. I'm afraid I'm not familiar with the names, but you'll know best. So again, here we're detecting faces and we're trying to match them to known people, right? So sports players, artists, politicians, business people, movie stars, etc., etc. Right? So very simple. So you can see that's how recognition works, right? We have a different API. So this is the detect celebrities API, I think. And you can compare faces. You can detect text in images. Yeah, we could try that. See if it picks up that flag. Yep. So we can see. So it actually detects. Oh, that's interesting. It detects some of the numbers on the jerseys, and it does detect the text here, right? And of course, again, we would see this in the response, right? We get the coordinates and everything, right? So this is the detect text API. What else can I show you? Yes, image moderation is kind of fun. So we can detect explicit content or suggestive content, and we also added violent content detection. So let's give it a shot. Okay, so what does it tell us? It says violence and weapon violence, which is pretty much what this is about, right? Okay, and you can see you get your simple JSON answer with the labels. Okay, so super simple to use. You can start using those things in minutes, right? And we recently added personal protective equipment detection, which is of course a major concern for everybody now. If you want to have an automated solution to make sure workers and staff are properly protected, then you can do that, right? So we can go and select face cover, hand cover, head cover, etc., right? And then we would know whether some people are correctly protected or not. That's a pretty cool feature. You can do the same on video. Pretty much all those features are available for video analysis as well. And another thing you can do with recognition is you can actually train your own model, but in a very simple way. You bring, it's called custom labels, and you can just bring your data. You bring your data to Amazon S3, right? And in a simple format, and then you train your own image detection model in there without having to go into crazy deep learning, etc., etc. So it's a pretty interesting solution. Okay, so that's recognition. Let's try Poly now. So I'm going to close this. So Poly is text to speech. Okay, so let me switch to my speech so that you can actually hear this. All right, let's give it a try.
Hi, my name is Joanna. I will read any text you type here.
Okay, so that's pretty much what it is. So this is the synthesize text API. You just pass the text, you pass voices. So each voice has a name and of course corresponds to a certain language. And you can see the list of languages here. So if we want to try, let's try Norwegian, why not?
Hei, jeg heter Liv. Skriv inn noe her, så leser jeg det opp.
Okay, so you'd call the API, say, hey, I want to say this using Liv's voice, and that's it. And either you save that output to let's say an MP3 file and play it later, or you get a byte stream that you can play immediately. Okay, so this is super simple, and you can see it has quite a few voices, right? Yeah, lots of different things. So we actually have different engines. So initially there was the standard engine, and then we came up with the neural engine, and the neural engine actually generates the waveform. So the sound file that you hear is actually a generated waveform built by a deep learning model. So it sounds more natural, it sounds more precise. This might be a little difficult to hear on the loudspeaker and the mic, but okay, let's give it a shot.
Hi, my name is Amy. I will read any text you type here.
Right, so it sounds just more fluid and simple. So let's try maybe a longer piece of text. Okay, so here's the standard voice, and let's try maybe Emma.
Barcelona presidential hopeful Toni Frakes has admitted that club captain Lionel Messi will have to lower his current wage at the club in order to renew his contract. The Argentine superstar's contract expires at the end of the current campaign, and he will be free to negotiate terms with other clubs from January 1st, should he not renew his deal ahead of that point.
Okay, so that's the standard voice. Pretty good. Now let's try neural. It should sound, again, probably difficult to hear, but you can easily run your own tests.
Barcelona presidential hopeful Toni Frakes has admitted that club captain Lionel Messi will have to lower his current wage at the club in order to renew his contract. The Argentine superstar's contract expires at the end of the current campaign, and he will be free to negotiate terms with other clubs from January 1st, should he not renew his deal ahead of that point.
So just a little bit more fluid, a little bit more, human-like. And there's another cool feature. So here I'm passing plain text to Poly, but we can actually pass SSML. So SSML is a markup language that lets us specialize how the speech is actually spoken. So let's grab a piece of SSML. Okay, and let's give it a try. So basically just tags, and I can use this newscaster style, and you'll see the difference. You'll hear the difference. What am I doing wrong now? Do you have a typo in there? No. Okay, just probably using the wrong voice.
Barcelona presidential hopeful Toni Freixa has admitted that club captain Lionel Messi will have to lower his current wage at the club in order to renew his contract. The Argentine superstar's contract expires at the end of the current campaign, and he will be free to negotiate terms with other clubs from January 1st, should he not renew his deal ahead of that point.
So you can hear that, there's this news broadcast style. This is really the type of speech you would hear listening to the radio or the TV, compared to the more plain tone that is used if we don't set this newscaster style. So this is pretty cool. You can do all kinds of funny things with SSML. You can speed up, slow down, insert breathing pauses to make the voice even more lifelike. So if you need to generate sound or voice messages for your applications, Polly is just a very, very simple and quick way to do that, and with very good quality. All right, let's move on. So Polly is text to speech. Now we can look at speech to text, right? And this is a service called Transcribe. And Transcribe has this cool feature called real-time transcription. So we can run batch jobs, just put some sound files in S3 and get transcriptions, but we can do it real time. So I'm going to try real time. And I'm going to try, I don't speak Italian or Spanish, and my German is pretty bad, so I'll stick to English. We have more languages for batch transcription, right? You'll find many more languages. For real time, we're only supporting those 4 at the moment. Okay, so let's give it a try. Hey, good morning, everybody. My name is Julien. I'm very happy to talk to you this morning and introduce you to machine learning. I hope you learn a lot and that you can start your own projects very soon. This is pretty accurate, and I'm quite satisfied with this demo. All right, that worked pretty well. So again, from an API perspective, what we're doing here is we're streaming data to Transcribe, and we're using the natural language processing capabilities to do a live transcription. So I'm sure you can imagine the applications here. You can do live captioning, you can do live transcriptions for audio and video content. We have customers who use this to transcribe university classes almost in real time. So by the time the class is over, then there's a transcription available, and you can share it with other students, or just archive it. Many different options here. Customer conversations, meeting notes. You don't need those anymore, right? If you have Transcribe, you don't need meeting notes. You'll have the notes, so you can focus on the meeting itself, right? So Transcribe is pretty nice. There is a medical version of Transcript for medical content, which is specialized with medical vocabulary, etc., etc. Same idea. You can do batch or real time, but it's been specifically trained to understand medical jargon, right? Okay, let's move on. So translate is pretty obvious, I think. So it's translation, of course. And again, we can do batch translation and real-time translation. Okay, so translate will automatically detect the input language, and you can see we have quite a few, right? And let's give it a try. So I'm going to start typing stuff, and let's see if we translate this to Ukrainian correctly. Okay, so you read Ukrainian, I don't. So let's check what I said. And let's translate this to maybe English. All right, yeah, that's what I meant. So hopefully this makes sense, right? So again, super simple service, and real time or batch, quite a few languages, including some pretty rare languages. We have some languages that I honestly didn't know about when they came out. So I had to actually read about them and figure out what part of the world those were from, and it's very interesting. So yeah, you'll find, I would say, I don't want to say all European languages, because of course there's always going to be one that's missing, but it's pretty much all of Europe, and a lot of Asian languages, and the African languages are there as well. So there's really good coverage now, right? Good coverage. And we have some variants, as you can see. Canadian French is a little bit different from French, and Mexican Spanish is a little bit different from Spanish, etc., etc. Right? So very cool service. And of course, I'm sure you have this idea already. You can combine those services, right? You can transcribe with Amazon Transcribe and take that output and feed it into Translate. And again, this is a single API call each time. So now not only can you transcribe your meetings or your classes, you can almost instantly translate them into a large number of languages, right? So very easy to combine those things. All right, let's do one more. So this one is Textract. So Textract is pretty much an OCR service, right? Optical character recognition service. But with a twist, we think it's a little smarter, because it can extract, of course, the text in scanned documents and PDF files, but it can also extract forms and tables. So let me show you here. Maybe let's grab this. Okay. So again, uploading this document to the service, or using a document in S3, calling the appropriate API, and getting a JSON answer. Okay, so it's a bit of a large document, and I don't have the fastest connection here. So let's see. All right, Textract, come on. Ah, here we are. Okay, so yeah, that's why you don't want to generally upload stuff. You want those files to be in S3, and call it from there, and then it's almost instant. Okay, so it's a research article, so the layout is, is pretty straightforward, I would say. It has some illustrations, it has tables, right? Yeah, quite a few tables. So, of course, we did detect the all the text correctly, right? So we can click on everything here and see, oh yeah, it's in there, right? But we want to see if we have tables, okay? Because of course, if you want to extract information from a document, if you just get the raw text in the table without any kind of structure, it's very difficult to use that information. There's a table here for good reason. So if you want to process this document, you want to keep the table structure, and this is correctly picked up by Textract. So if you look at the JSON answer for this API call, you will see this table structure defined inside the JSON answer. So then you can, maybe convert this to, I don't know, HTML, or you can push it into a backend. But at least you keep this data structure here, right? So let's try maybe a form. Proper form. So I think this is an insurance form, and of course I'm sure your companies use forms, most of them. So this is an easy way to process them. So again, the text is correctly detected, but more importantly, we can see the forms, right? So we can see that address 123 Paradise Road is detected and associated to the label for that box in the form, right? So now you can really understand that these things are related, and of course you can insert this in your database and do whatever you have to do with it, right? So that's pretty nice. Okay, and the table here again is correctly detected. Okay. So this is a really nice service, and that's for sure. It's a problem that a lot of people have, figuring out what's in their documents, and Textract make it, I think, pretty easy to solve that. Okay. All right. Let me show you quickly personalize, and then we'll move on to machine learning services. So, and the philosophy of personalize and forecast and fraud detector are very similar. So if you understand one, you understand all three, I think. Okay. So the problem I'm trying to solve here is, where's my editor? Here it is. Okay. I have a data set that looks like this. It's actually, it's called the Movie Lens data set, and it's a popular data set for movie recommendation. So what does this data set tell me? It says, well, I've got movie recommendations for certain users. So user 298 has liked item 474, right? Imagine this coming from Netflix app, and thumbs up, thumbs down, and this is the timestamp. Okay, so I've got all this information here, and I've got tons of those, and I'd like to build a movie recommendation model. And recommendation is, I believe, one of the harder problems in machine learning. Models are really complex. Data processing is very complex. So very few companies have the expertise to do that. So what we've done is we've built a service called Amazon Personalize, where all you have to do is bring this data and upload it to S3, call some APIs to train a model, deploy it, and predict. And baked into the service are all the best practices that Amazon has learned over the years for data preparation and algorithm selection and algorithm tuning, etc., etc. So you really, even if you have no machine learning expertise, you can do this. So the steps are really those, right? Upload the data. So it could be historical data like what we have here. You can also stream data, right? So you could stream those likes directly from mobile apps or web apps. And then you create a solution, which is basically a recommendation model. You launch a campaign, which really is deploying the model, and then you can predict. Okay, so basically it's one API call for each of those things. So upload the data set, right, which is this file that you saw. It's called the user item interaction dataset because it's exactly what this shows, interactions between items and users. We could also add item information. If we had metadata on items and metadata on users, we could add that to the mix for increased accuracy, but this is the only mandatory one. And then I train a solution, and let me show you how you do this. You give it a name, and then you select a recipe, which is really, okay, what am I trying to do here, right? Am I trying to do similarities? Am I trying to do personalization, right? Or you can just say, there's actually an AutoML element here as well, where you can just say, now go and figure out what I'm trying to do. And then once you've trained the model, you deploy it to a campaign. Okay, and so you get a prediction API, right, which you can invoke, but here I'm invoking it with the console, and I could say, hey, give me recommendations for user ID 123, and immediately I get recommendations for movies, and I get scores telling me, how high, we should, if we want to only take the top 5 or the top 10, okay, these are the top 10 recommendations, right? And I'm going a little fast here, but this is really what it is. And then you can run that. You can run the tutorial, and you'll see that even without any machine learning expertise, you can get your model ready, and you have this prediction API that you can invoke and plug, connect to your website or your mobile app, and then generate recommendations, right? And using your own metadata, you would know, movie 137 is whatever movie, and display the image for the movie and the title, etc., etc. But the machine learning part is completely taken care of. Okay, and again, forecast works the same for forecasting time series data, and fraud detection works the same for building fraud detection models. Okay, so very, very cool way to quickly get your models in production. Okay, so we've taken a look at quite a few of those, and now let's take a quick look at machine learning services. Okay, so machine learning services really mean Amazon SageMaker, right? And SageMaker was launched at reInvent 3 years ago, and over time we've added tons of different capabilities. So I will stick to the simple capabilities today, because again, this is an introduction, and there's no need to go too deep on all those crazy things here. But I will share some resources if you want to know more. Okay. So remember that machine learning cycle that we saw early on. This is kind of another way to express it. We need to prepare data. We need to build data sets and build models. We need to train models. We need to debug them. We need to optimize their accuracy. And of course, over time, as we iterate, we end up training hundreds of different models. So how do we keep track of everything? How do we compare them? That's another problem. And of course, the deployment and ops part, which is all about quality of service, quality of predictions, making sure the model predicts the way it should, and then of course scaling and high availability and all those good things, right? So that's really what we're trying to solve with SageMaker. And like I said, over time we've added lots of different capabilities to do all of this. Okay, from data labeling to data preparation, to development environments, to training environments, and advanced capabilities for model debugging and model tuning and model tracking. And then, of course, deploying and scaling your models automatically, detecting prediction quality issues, etc., etc. Right? So we're trying to cover the full spectrum so that you can really use your one service and one SDK to go all the way from experimentation to production, right? Now, having said that, some customers, they don't need the end-to-end experience, right? They just have a particular problem. So let's say you want to train in the cloud because you want to leverage, the GPU instances that we have, but then you want to grab the model and deploy it on premise because you have this constraint. That's okay. You can absolutely do that, right? Some people do it the other way. Some people have an existing model that they train and it works and it's still relevant, and they want to deploy it in the cloud because they want to scale there. So you can import the model to SageMaker and work like that. So even though we're trying to build this end-to-end experience, the last thing that we want is to say, oh, you have to go from A to Z. This is how Amazon is doing machine learning, and if it works for us, it works for you, right? And that's really, really not what we're about, okay? So we build the end-to-end thing, but we also make sure you can use each of these modules independently and just cherry pick what you need for your own workflow, okay? This is really important to me. So let's just give you a quick overview of what modeling options are available. So the first option is not to train anything at all. We have a specific category in the AWS marketplace for machine learning models. So these are algorithms and models that have been designed and trained by AWS partners and that we checked, of course. And so they're readily available for deployment. So you can just go to the AWS marketplace for machine learning, find a model that you like, that kind of looks like what you're trying to do, deploy it in SageMaker in just a few clicks, experiment with it. And if it works, then fine, job done, right? And most models are free to test, so you don't take any risks. And then if you want to deploy them for good, then you pay whatever fee the partner has defined for that model. Okay, but it's just a great option. We have hundreds of models in there, and they may very well save you from having to build everything yourself. The second option is a capability called SageMaker Autopilot, and it's AutoML for SageMaker. So you can kind of similar to Forecast, but and personalized. All you have to do is bring your data to S3 and define the column in the data set, the target value that you want to predict. And this works for regression and classification problems. And then Autopilot will automatically build a model for you, right? And it's not an opaque model. You actually get auto-generated notebooks that show you exactly which candidates were evaluated and how data was processed, how the model was optimized, etc., etc. And of course, you can replay the notebooks if you want to replay the AutoML process manually. Okay, so that's a very cool feature there. Now, of course, a lot of people who use SageMaker will want to use different algos and have a wide selection. So the first option, when it comes to actually training and selecting the algorithms yourself, is to use built-in algos. So we have 17 algos today, which are hosted in the different regions that SageMaker is available in. And there's statistical machine learning algos and some deep learning algos covering typical problems. And the good thing about that is you don't need to write any machine learning code. You only need to select one of those algos and use it to train, right? So if you're not familiar, or if you want just to not familiar with ML, or if you want just to go quickly, then these do the trick. Okay. The second option is to bring your own code. So maybe you wrote code for TensorFlow, maybe you wrote code for PyTorch, and so on, or XGBoost, and you have existing code and you want to run it on SageMaker. And I'll show you a demo of that in a minute. And this is extremely easy to do, right? This is extremely easy to do. So you can bring your own code and use it to train and deploy models on AWS. So if you're curious how those frameworks work, well, they're hosted in containers, right? All training and deployment activity is container based in SageMaker, and we open source all those framework containers. So you can inspect them, train them yourself on your local machine, customize them, push them again to AWS to use them on SageMaker. I mean, you have complete freedom here. And the last option is full customization. If you need, for example, other languages like R or C++, or maybe you have your custom, you have a full custom Python container with all your dependencies, that's okay. You can build it, push it to AWS, and use it on SageMaker. Okay, so lots of different options here. Okay, and the common theme here is training and deployment, for that matter, is fully managed. So you never worry about building and managing infrastructure. And you can even use spot instances for training, which is a very powerful technique to slash training costs up to 75, 80%, right? So lots of options. Bring your own code. Don't worry about infrastructure. Okay. So let me show you how this works. Okay, we can close this. So this is the SageMaker console, and then here I'm actually using our web-based IDE for machine learning, which is called SageMaker Studio. Okay, so I opened it already. It's based on Jupyter. You'll be super familiar with it. There's nothing really strange about it. And let's run the first example based on XGBoost. So let me close this, maybe zoom in a bit. Hopefully you can read okay, right? So let me quickly check. Yeah, this is okay. Okay, so here the problem I'm trying to solve is I want to predict house prices based on a historical data set. And this is a well-known toy data set called the Boston Housing data set. Okay, and we can see some of its samples here. So it's a CSV file. We read it with pandas. We display the first 5 lines, right? And it has a number of features. So, how much crime is in the area and how much pollution is in the area, and the distance to the city center, and the tax level, the things you would typically look at when you're trying to price a house. And the value of the house is actually this thing, the median value. So this is in thousands of dollars. It's a pretty old data set. So at the time, I guess you could buy a house for $24,000. Not sure you can do that today, but that's not the point. So anyway, that's the value we want to predict based on all those features. Okay, so that's the business problem. And it's reasonably simple to understand. It's a regression problem, and the metric we want to use here is how close do we get to the actual prices here, right? So we're going to use a mean square error metric that gives us a sense of how well we're doing on this data set. Okay, so we have 506 data samples. That's not a lot, but for our purpose, it's okay. All right. So there's not so much data preparation here. I just need to move that first column to the front because that's what XGBoost expects. The first column in the data set should be the value that you want to predict. Okay. So moving that column here. And then I'm splitting the data set in 2 parts. One that I'll use to train the model, and one that I use to check the model accuracy. This is called the validation data set, right? So you train on the training set. So of course the model understands those samples very well and is trying to predict them as correctly as possible. but the model doesn't train on the validation data set. So checking on the validation data set gives you a sense of, does my model generalize to data it hasn't seen before? That's a really important practice, right? Don't use all your data for training. So I take 90% for training and 10% for validation, okay? I save those different data set to CSV files, okay? And I'm done with data. And now we can start with the actual SageMaker workflow, which is very, very simple, as you will see. So everything is based on the SageMaker SDK, which is a Python SDK to manage all training deployment activities inside of SageMaker. Okay, so I import this. The first thing I'm doing is I'm uploading my 2 data sets to Amazon S3. Okay, I'm creating a default bucket for SageMaker here, and I'm just putting those 2 CSV files in there. Okay, all data needs to be in S3, of course, right? We're using the cloud, remember? And we can see the 2 paths here, right? Okay, training set, validation set. Okay, that was very simple. Now, based on our experience, this is a regression problem, and we know that XGBoost is a good algorithm. It's a tree-based algo, just like the one I showed you earlier, and it's a good algo for regression, right? It can do other things, but it supports regression. So let's give XGBoost a try. So this is one of the built-in algos in SageMaker. So all I have to do is say, please give me the name of the XGBoost container in the AWS region I'm running in, right? And here you can see in my URL, I'm using the EU West 1 region in Ireland. Okay, so give me the name for the XGBoost container in Ireland. And that's all I need to do, right? This is enough. And now I can move on and configure my training job. So using this estimator object from the SageMaker SDK, which is the generic object to configure training jobs. I pass the container, the role, which is basically permissions, allowing me to access files, shouldn't say files, objects in S3, to pull the container, etc., etc. This role is taken care of when you set up your SageMaker Studio environment. And then I have to decide how much infrastructure I want to train on. So here I'm training on an M5 large instance, which is a good general purpose, medium size instance. Definitely more than enough for a simple training job like this. And this is as much infrastructure work as I will do here, right? Nothing more. No need to fire up machine learning, no need to fire up virtual machines, no need to set up networking, etc. Right? If you're used to working with Amazon EC2 and VPCs and subnets and so on, there's nothing like that here because SageMaker takes care of that for you. So if you don't like infrastructure, you'll be happy here. And then the output location, where to save the model in S3 again. All right. Okay. The last thing I need to do is to set some parameters for this training job. Of course, these are fully documented. Here, I'm doing regression. Okay, so I set the appropriate objective for XGBoost. Again, we could do classification and other things. I decided to train for 200 rounds, and you can say, why 200? And the answer is, I don't know. Sounds like a high enough number to get good accuracy, but in case accuracy stops improving after 10 rounds, then I want the training job to stop. Okay, simple. And of course, there are more black magic parameters, but in general, if you don't know what you're doing, then don't touch them, right? We have reasonable defaults, and they should be good enough. So just set the ones that are mandatory, or the ones that you really know, what they're doing. So here, let's play it safe, stick to the simple things. All right, and the last step is just to define our 2 training channels. So training channels are basically data sources that the algo will use. So we have a training channel, we have a validation channel. We pass the appropriate locations in S3, and we pass the data format, which is CSV. Okay, and then we call fit on the estimator, and we get the trading job going. Okay, so you see, from a machine learning perspective, we didn't do anything here, right? We basically put some CSV files in S3. We selected XGBoost. We just told XGBoost, hey, this is what we'd like to do, linear regression. And here's where the data is, and it's CSV, go do your thing, right? So very, very simple. So when we call fit, we see what's happening from an infrastructure perspective. So we start the training job, we launch that instance that we selected, that M5 large instance. Data is copied to that instance from S3 to local storage. Of course, the XGBoost container is pooled, and then SageMaker gets everything going, right? And we see the training log. And of course, it's also available in Amazon CloudWatch, which is the monitoring service. So here, if I'm running a notebook, but if you were running this as a script, as a standalone script, or maybe in a Lambda function, or in a container, anywhere, then you would still get your log in CloudWatch. So we see all those rounds taking place. We can go down. So that's the metric, the root mean square error. And yeah, it stops going down after a while. So yeah, we can see, that early stopping ID was a good ID because we only trained for 37. Well, we trained for 47 rounds, but the best one was actually 37, which is why we stopped 10 rounds later. Okay, so the model is saved in S3, the job is complete, the instance shuts down automatically, and we only pay for 59 seconds, right? So there's no chance we're going to leave this instance on because it's terminated automatically. So you will never overpay for training. By design, it's not possible. Okay, if I use spot instances, I would probably get a 70-75% discount on this. So I would just pay for fractions of just maybe a couple of, not even a couple of cents, fractions of a penny, right? Okay, so now we have a model. We could go and grab that XGBoost model in S3. We could copy it to our local machine. We could do some local testing. We could do all kinds of things. Okay. But let's continue and let's go and deploy. Okay, so we're going to deploy, calling the deploy API, right? And again, we just say, hey, here's a simple a basic instance I want to deploy on. So it takes a few minutes, and I actually go to the console and see that yes, I have my endpoint. Okay, so zoom in here. That's the one you see here. So it's an HTTPS URL that I could invoke using any language, any tool, right? Push data and get predictions, right? And this is running on a fully managed instance. So here I'm going to just call the predict API, which is in the SageMaker SDK, passing some test data, right? So I'm serializing and deserializing using a CSV. And I can see the predicted price for this house is $23.95 K, right? And of course, I can pass multiple samples and get more answers. Okay. And when I'm done, I just delete the endpoint, right? And that endpoint comes down, and I stop paying for that. Okay. So you have to be careful here. Training shuts down automatically, but endpoints are not shut down automatically, right? I don't think you'd like it if we shut down your endpoints. So of course you have to take care of that. Okay, so it's good practice to, once you're done working, just go to the console and look for endpoints and terminate anything that could be running there. Okay. All right. So really quickly, we could do the same with a scikit-learn script, right? So let me just show you the difference. So I'm using the exact same data set, but this time I'm training with a little bit of scikit-learn code that trains a linear regression model, exactly the same idea here. And you can see I'm using the sklearn estimator. So I don't have to say, hey, use the sklearn container. Obviously, yes, that's what we want to do, right? And I just pass my training code here, and I do the same, right? And I train, and I deploy, and I predict. And there's nothing weird in the in that scikit-learn code. Here it is. If you're used to scikit-learn, it's vanilla code all the way, right? I'm not even importing anything related to SageMaker here, right? The only thing is, so of course you need to receive hyperparameters on the command line. That's how SageMaker will pass them to the script. And you need to read the location of the data sets and the location of the output model using environment variables. That's it. Okay, so you can take your existing framework code, add those 2 lines here, basically, to know where to read the data from and where to save the model at, and you can use it on SageMaker, right? So accordingly, I read the data from that location, and I save the model in the right location, and that's it. So very, very minimal changes. Okay. All right, there's so much more I could say here, but this is good enough, I think, for a first intro. Maybe just a quick few words on the frameworks and infrastructure, and then we can move on to questions. So frameworks and infrastructure are at really the bottom layer, and so this is for customers who want to build and manage their own infrastructures. Some customers are more comfortable doing that, and that's fine. So like I said, you have plenty of different instance types: CPU, GPU, FPGA. We have a special custom chip called Inferentia that lets you accelerate machine learning predictions at very, very high throughput and very, very low cost. This is really a good choice if you have large-scale prediction workloads. And of course, you can use Amazon EC2, and you can use our container services, ECS, EKS, etc., to build your training and deployment clusters. Like I said, we have Amazon Machine Images for this to save you the trouble of installing and managing all those libraries. We have deep learning containers for your container services as well, and they basically include all those libraries that you see there, and those are in most cases optimized versions of those libraries. We have teams who actually work on making TensorFlow train as fast as possible on AWS and so on. So there's a lot of benefit also in using those. Okay. All right. So some resources that I think could be useful. So if you want to know about everything then that I discussed today and more, then you should go to ml.aws. This is really the high-level URL for everything. If you're specifically interested in SageMaker, then here's the SageMaker service page, the GitHub repo for the SDK that I used, the GitHub repo for hundreds of notebook examples showing you all the configurations that you can use SageMaker with, from the very simple ones to the crazy advanced ones. This is my YouTube channel and my blog, where you could find some interesting content if you want to dive deeper on SageMaker particularly. And last but not least, I wrote a book on SageMaker that was published a few weeks ago. And you can find discount links for the paper edition. Unfortunately, this is just good for Amazon.com, but it's a very deep discount, so it's possible that it would offset the shipping cost as well. Some depending on where you live, it might actually be cheaper than other options. And in any case, you can also buy the ebook on the publisher website on Packet using that 20 SageMaker code. Okay, and that gives you 20% of the price. So this is only valid for a few more days, so don't wait if you're interested. If you're not, that's totally okay. But don't ping me on November 12th saying, "Oh, I forgot," because I'm sorry, I don't think I will be able to help.
Hi, Julien. Thank you for waiting for a second. It's Ira, your moderator. If you have a few minutes for Q&A session, so you can follow to a Zoom room and meet your participants here and answer all the questions here.